Ever felt like your MIDI controller has untapped potential? Like it could be whispering secrets you're not quite hearing.
Yeah, that feeling that there's more under the hood.
Exactly. Well, today, we're plunging into a really fascinating piece of hardware that could unlock those secrets. The Doepfer MCV24 MIDI to CV gate interface.
Ah, yes, the MCV24, a classic bridge between worlds.
You shared its incredibly detailed manual with us. Thanks for that, by the way. And we've sifted through it to bring you the most exciting insights.
Think of it as learning the language, right? The language that lets your digital gear talk to your analog synths.
Precisely. That warm, organic sound, finally understanding MIDI commands. What's really at the core of this thing?
Well, its main job, its raison d'etre, is bridging those two musical worlds. It takes MIDI signals, notes, controller data, that sort of thing.
The stuff from our dead oldies or keyboards.
Right, and it translates them into control voltages, CV, and gate signals.
And those are the signals that analog gear actually understands.
Exactly. CV and gate are the native language for a lot of analog synths, drum machines. It allows for really direct, nuanced control over their sound.
Okay. And our source material today is primarily those wonderfully thorough German and English manuals you sent over. They're our map for this.
They are quite detailed, aren't they? Lots to unpack.
Definitely. So our mission for this deep dive is to really eliminate the key features and honestly the sheer potential of the MCV24.
Highlighting those aha
Yeah.
moments.
Where MIDI control clicks with analog sound sculpting.
Mm,
Let's dive in and see how this interface acts as this powerful translator, opening up a really vast landscape of sonic possibilities.
okay. Where to start? I guess the first thing that jumps out is just the breadth of control.
How so?
You're looking at a front panel with 24 analog control voltage outputs.
24. Wow.
Yeah, all on standard 3.5 millimeter jack, so easy connection. That's a lot of potential links to your analog gear.
24 outputs. That's like giving your computer, I don't know, 24 hands to tweak analog knobs simultaneously.
Haha, yeah, something like that. And what's really clever, as the manual points out, is that they aren't all identical.
Ah, okay. How are they different?
They're organized into 3 distinct groups labeled A, B, and C. Each group has different voltage ranges and different resolutions. They're kind of tailored for specific tasks.
Okay, tell me about Group A.
Right, Group A covers outputs 1 through 4. These operate in a -2 volt to +8 volt range. And the key thing here is the precision. It's incredibly high,
Wow, I.
down to a 64th of a semitone resolution.
Whoa, that's tiny. Why so precise?
Well, that level of fine control makes these outputs perfect for really nuanced pitch control. Think complex modulations, microtonal stuff, or just super smooth pitch bends over a wide range without any audible stepping.
Okay, gotcha.
Plus, you can actually tweak the offset and the spread for each of these outputs in the software, so even more granular control.
Makes sense. And Group B outputs 5 to 12.
Yep, these are more standard maybe. They run from 0 to +10 volts, and they're specifically optimized for the volt octave pitch control standard.
Ah, volt octave. That's pretty common in Eurorack in many sense, right?
Very common. It's that standard where, every 1 volt increase equals a 1 octave jump in pitch. Makes interfacing different gear much easier.
And the resolution here? Still pretty good.
It's a quarter of a semitone. The manual even helpfully breaks it down. One semitone is about 0.083 volts. So still accurate for standard pitch control.
So when would you pick Group A over Group B for pitch, if both can do it?
Good question. I'd say Group A gives you that extra fine control, maybe for experimental stuff or wider, smoother bends, like I said. Group B is your reliable workhorse for standard volt octave synths, probably easier to set up for typical melodic playing.
Okay, that clarifies it. And the last group, C, outputs 13 to 24.
Right. These also run 0 to +10 volts, similar to Group B, but the resolution is a bit coarser, 0.04 volts per step.
Still useful, though.
Oh, absolutely. Maybe not ideal for superfine pitch, but perfect for most controller voltages. Things like filter cutoff, envelope amounts, LFO speeds, VCA levels, that kind of thing.
And they can do gates, too.
Yes. Importantly, these outputs in Group C can also be set up to send gate signals. And you can even choose the polarity.
Polarity, you mean like positive or negative voltage for the on signal?
Exactly. Some gear triggers on a rising voltage, positive gate. Some needs the voltage to drop or stay high, S-trig for example. Selectable polarity means better compatibility with a wider range of vintage and modern gear.
So a gate is basically the note on, note off signal for analog stuff. tells an envelope when to start and stop.
That's a great way to put it, yeah. Starts the envelope cycle. So you see how the MCV24 starts to look like this central hub in a hybrid setup?
Yeah, connecting the digital brain to the analog muscle.
Uh-huh.
Okay, it's clearly versatile, 24 outputs, different types. But with all that, is it a nightmare to actually use? The manual says intuitive operation.
Yeah, well, intuitive can be subjective, but they've made an effort. The main interface relies on 3 alpha dials. Rotary knobs you can also push.
Okay, like endless encoders with a button.
Yeah,
Click.
pretty much. One selects the output channel you want to edit, another navigates the menus and submenus, and the third one changes the values and, crucially, confirms them.
And you see what you're doing
A
on.
backlit 2x16 character LCD display. The manual makes a point that it uses plain text or, meaningful abbreviations, not just cryptic codes, hopefully.
That's always a plus. How's the menu structured? Is it just one long list?
No, thankfully, there are about 100 parameters, which sounds like a lot.
It does.
But they're organized into 7 main menus labeled A through F. That structure should help keep things from feeling too overwhelming.
Okay, manageable chunks. And I saw something about the output channel button doing different things. Context dependent.
Yeah, that's quite neat. Depending on where you are, pressing that button can cycle the display. It might show the output number or the preset number you've loaded,
Okay.
or even the MIDI controller number assigned to that output instead of just its name, or the MIDI note number. It gives you quick access to key info without digging deep into menus again.
Okay, so Doepfer seems to have put some real thought into making this depth accessible. Good. Now let's get into the real core of it, the CV configuration. The manual mentions CV1 and CV2. What's that about?
Right, this is where it gets really powerful, I think. Internally, for each of those 24 physical outputs, the MCV24 is actually calculating 2 independent control voltages.
2 per output.
2 virtual CVs per output, yeah. They call them CV1 and CV2. These 2 are then combined internally before they get sent out the physical jack as a single analog voltage.
Whoa, okay, 2 layers of control for each output. That opens things up. So you can assign different MIDI messages to control each one.
That's exactly it. For both CV1 and CV2, independently you choose which MIDI command drives it.
And what are the choices?
Pretty comprehensive. You've got standard MIDI note events, playing a key, MIDI controllers, mod wheel, foot pedals, breath controller, whatever, polyphonic aftertouch.
The pressure on individual keys after they're down.
Yep. Then monophonic aftertouch, the overall keyboard pressure, pitch bend, obviously, or you can just select no MIDI command.
Why would you choose no MIDI command?
Maybe you want that CV layer to be static or controlled by one of the MCV24's internal LFOs or envelopes, which we'll get to.
Ah, okay. Internal modulation sources. Got it. So that's a huge amount of routing flexibility right there.
Yeah.
And I bet the menus change depending on what MIDI command you pick for CV1 or CV2.
You bet. If you assign, say, a note event to CV1, the next menus will be about how it handles notes, maybe setting the MIDI channel, the bass note, things like that.
And if you choose a controller.
Then you'll see options to set the controller number you want to respond to, and maybe upper and lower limits for its range, within that 0 to 127 MIDI range.
Same logic for poly aftertouch, I guess. Selecting which note's pressure.
Exactly. You specify the note number range, 0 to 127 again. It tailors the parameters to the MIDI command you've selected.
Okay, let's look at some specific parameters mentioned for CV1, and the manual says CV2 has similar options. MIDI channel, that's straightforward.
Yeah, assign which of the 16 MIDI channels that virtual CV should listen to. Lets you control different analog parameters from different MIDI tracks, for instance.
Makes sense. Then note selection mode, only relevant if you chose note events, right? What kind of modes are we talking about?
The manual doesn't list all of them, but typically you'd find things like last note priority, the most recent note played gets the CV, or highest note, lowest note. Maybe even modes to help play pseudo-polyphonically on monosynths by cycling notes across outputs.
Ah, okay. Ways to handle multiple incoming notes intelligently.
Right, it helps the MCV24 decide which note matters most in different playing situations.
Then there are lower and upper limits for note or controller numbers, so you can make only the top half of your keyboard effect a filter, maybe?
Precisely. Or only have the first half of your mod wheel's travel control something. It's great for focusing control ranges or avoiding unwanted extreme values.
Very useful. And then slew limiter. On-off and a slew time setting. What's that do again? Sounds familiar.
Yeah, we touched on it briefly. A slew limiter, sometimes called portamento or glide, smooths out voltage changes. Instead of jumping
And
instantly,
skipping between notes.
right, it creates a smooth slide between voltages over a set time. So you get that classic pitch glide effect or smoother sweeps for filters or other parameters.
And the time is adjustable.
Yep, slew time is adjustable from off up to a value of 127, giving you a wide range from instant to very long glides. And this applies to both CV1 and CV2 independently, which is cool.
Very cool. Now, for node events specifically, it looks like there are dedicated velocity options. Velocity being how hard you hit the key.
Absolutely. And it's not just a simple velocity controls volume thing. For node events on CV1, and the manual says this applies to the first 4 outputs.
Oh, high precision ones.
Yeah. You can choose no velocity influence or have velocity directly control the CV level or use velocity to control parameters of the MCV24's own internal ADSR envelope.
Control the envelope.
Like hit the key harder, the attack is faster, or the overall envelope level is higher. Or you could have velocity control the depth of the internal LFO modulation. Or even control the slew rate we just talked about.
Wow, velocity controlling glide time. That's deep.
It really is. You can even set the slew time for velocity itself. The level of detail is quite something.
Okay, and it keeps going. Trigger generation for node events. So alongside the main CV, you can generate a separate trigger pulse.
Yes. When a node event happens, you can tell the MCV24 to also output a trigger. Again, you have options.
Like what?
No trigger at all. A direct CV conversion, maybe just a short voltage spike. Or you can use the node event to trigger the internal ADSR envelope generator to start.
So the note plays the pitch and starts the envelope shape.
Exactly. Or you could trigger the internal LFO to reset its cycle. There's even a retrigger time parameter you can adjust.
Retrigger time. What does that control?
It likely affects how quickly a new note can retrigger the envelope, or LFO, especially if the previous note hasn't finished its release phase. Good for controlling legato playing versus distinct note attacks.
Got it. Finally, in this CV section, there's a scaling factor for CV2. What's that for?
That basically acts as an attenuator or volume control just for the CV2 signal before it gets mixed with CV1.
So you can adjust how much influence CV2 has on the final output.
Precisely. It ranges from 0 to 255. So if CV1 is doing pitch and CV2 is adding vibrato from an LFO, the scaling factor lets you dial in exactly how much vibrato you want mixed in.
The manual gives an example, right? Something about octaves.
Yeah, it mentions that on outputs 1-4, a scaling value of 48 for CV2 roughly corresponds to 1 octave in volt-octave mode, assuming CV1 is also set for pitch. So it gives you a reference point.
Okay, the CV config is incredibly deep. But you mentioned internal modulation sources, LFOs, and ADSRs built into the MCV24 itself.
That's right. It has software-generated low-frequency oscillators, LFOs, and ADSR envelope generators.
Software generated. So not true analog circuits inside.
Correct. The manual is careful to point that out. They might not behave exactly like pure analog hardware modules, but having them built in and controllable via MIDI hugely expands the possibilities without needing extra external modules.
Makes sense. What kind of LFOs are we talking about? Waveforms?
A good selection.
Yeah.
You get linear, which covers both triangle and sawtooth waves, rectangle or square wave, sine wave, and then 2 types of random voltage. Analog random and digital random.
Analog and digital random, like smooth random versus stepped random.
That's usually the difference, yeah. Smooth, fluctuating random versus stepped, sample and hold style random covers a lot of modulation ground.
And the parameters for the LFO, what can you control?
Quite a lot. There's an on-off switch, obviously, waveform selection. Sync options, run it free internally or sync it to MIDI clock.
MIDI sync is crucial.
Definitely. Then coarse and fine frequency controls, covering a range from super slow, like 0.01 hertz, up to about 20 hertz, well into the modulation range.
And for MIDI clock sync.
There's a divider setting, 1 to 255, letting you create rhythmic LFO patterns based on the incoming clock tempo. Also a ratio parameter, probably pulse width for the rectangle or shape for the linear waves. Modulation depth for amplitude, and an offset control too.
Offset, to shift the whole wave up or down.
Exactly. Shifts its center point, which can be very useful.
Okay, versatile LFO. What about the ADSR envelope?
Standard stuff here, but very welcome. You get attack time, decay time, sustain level, and release time, all adjustable from 0 to 127.
The classic envelope stages.
Yep. Plus, a modulation depth parameter to control how much the envelope affects whatever it's modulating, and a simple on-off switch for the whole envelope generator.
So you could use this internal envelope, triggered by MIDI notes, to shape, say, a filter cutoff on an external synth module.
Absolutely. Or shape the amplitude using an external VCA, all controlled from the MCV24.
Now, things get even wilder, it seems, with the modulation matrix. What does that let you do?
This is like a central routing hub for modulation. Per output, it lets you assign up to 6 different MIDI commands to control various internal functions and parameters in real time.
6 MIDI commands per output.
Wow.
Which MIDI commands can be sources?
The continuous ones. Controllers like mod wheel, breath, pedals, polyphonic aftertouch, monophonic aftertouch, and pitch bend.
So, stuff you're actually performing on your controller.
Exactly. Things you can manipulate live.
And what can these incoming MIDI messages control within the MCV24?
They can modulate parameters of the internal ADSR attack, decay, sustain, release, and its modulation depth. They can control the LFO's modulation depth, and they can even control the slew rate of that slew limiter we discussed.
So, I could use my mod wheel to dynamically increase the LFO depth, or maybe use aftertouch to shorten the envelope release time.
Precisely. It allows for really expressive dynamic control over the generated CVs, all mapped directly from your MIDI performance gestures. It's a powerful feature.
Definitely sounds like it. Okay, beyond all these per output settings and internal modulators, there are also global system parameters, right? For tuning the whole device.
Yes, these are crucial for getting the MCV24 to play nicely with your specific setup. Simple but useful stuff first. You can give each of the 24 outputs an 8-character name.
Helpful for remembering output 7 equals filter cutoff.
Exactly. And you can name each of the 16 presets, too. Makes organization much easier.
Good. What else?
More fundamentally, you can select the control voltage standard you need, the common volt octave or the less common Hertz volt.
Hertz volt. Which synths use that?
Some older Korgs, like the MS-20, and some older Yamahas used Hertz volt. Having this option makes the MCV24 compatible with a wider range of vintage gear.
Very important for owners of that gear. And calibration. Why calibrate the voltage range?
This is absolutely critical for accurate pitch tracking, especially with volt octave. Analog oscillators aren't always perfectly consistent.
They can drift a bit or respond slightly differently to the same voltage.
Exactly. So the calibration lets you teach the MCV24 how your specific synth responds. You define a couple of MIDI notes, say a low C and a high C, and then fine-tune the exact voltage the MCV24 outputs for each of those notes until your synth plays them perfectly in tune.
So you're compensating for the synth's quirks.
Precisely. It ensures accurate tracking across multiple octaves, essential for melodic work.
Okay, and for the gate outputs in Group C, you can adjust the trigger voltage levels. Why?
Because different modules might expect slightly different voltage levels to register as on or off for a gate signal.
Their trigger thresholds might vary.
Correct. So the MCV24 lets you set the logical on and off voltage levels for each trigger output individually as a percentage from 0 to 100%. This ensures reliable triggering across diverse gear.
Smart. Lastly, in system params, global sync parameters for D-on sync.
Yeah, if you happen to have older Roland gear or other devices that use D-on sync for tempo.
Like old TR drum machines or the TB303.
Those are prime examples. The MCV24 has dedicated DIN sync outputs, and these parameters let you set the sync rate division in 96 notes, the standard, and the polarity of the start-stop signal to match your specific DIN sync device. Great for integrating vintage pieces.
Okay, with all these settings, saving your work is vital. It has 16 preset memories.
Yes. 16 non-volatile memory slots, meaning they remember the settings even when powered off. You can store your complete configurations, all the CV assignments, scaling, LFO DSR settings, mod matrix routings, everything.
And you can manage these presets.
Yep. The manual mentions functions to copy presets between slots and also copy them to and from a temporary edit buffer. So you can tweak a sound without overwriting your stored preset until you're sure.
Good workflow feature. And backups. What's SysX dumping?
SysX, or System Exclusive, is a part of the MIDI spec that lets devices send custom data, like their internal settings.
Yeah.
The MCV24 can dump a preset or even its entire current state as SysX data over MIDI.
So you can save it to a computer or share it.
Exactly. Essential for archiving complex setups or sharing patches with other MCV24 users. You can also load SysX data back into the unit. It also mentions handy functions for copying parameters between output channels, saves time if you're setting up similar controls on multiple outputs.
Okay, practical stuff. The manual also flags some important operational things to be aware of.
Yeah, a few key points for smooth operation. One is the value button. It doesn't just set values.
What else?
If you press it when you're in the main menu, it triggers a recalculate data function. The manual describes it as reorganizing the software internally. Sounds like something you should do periodically, maybe after making lots of changes, to ensure stability.
Interesting. Good to know. And warm start versus cold start.
Right. Warm start is just turning it on. Normally it remembers everything. A cold start is different.
How do you do a cold start?
You have to press and hold all 3 front panel buttons while powering it on, then release them. This resets almost everything back to factory defaults.
Wipes your settings?
It wipes the current working memory, yes. Not the saved presets, thankfully. But the manual warns you, be careful not to do this accidentally while editing because you'll lose all your unsaved work in the edit buffer.
Ouch. Good warning. It also uses this interesting analogy for the operating system, like an internal modular synth.
Yeah, I like that. It says the OS is dynamic. Software modules for the CVs, LFOs, envelopes get activated or deactivated based on your settings. Connections are made and broken internally all the time.
So it's constantly reconfiguring itself.
Seems so. That's what gives it its flexibility. But the manual also cautions that this dynamic system has limits. If you try to run everything simultaneously in a super complex patch,
You might overload the processor.
essentially, yes. You might notice the display lagging slightly, or maybe the LFO frequencies aren't perfectly stable. It's just a reminder that even powerful digital systems have processing boundaries.
Fair enough. And one final practical tip about powering off.
Yes, a very sensible warning. When you switch the MCV24 off, the analog outputs might briefly spit out undefined voltages.
Could cause pops or loud noises.
Potentially, yeah. So the advice is simple. Turn down the volume on your connected amps or mixer before you power off the MCV24. Saves your ears and your speakers.
Definitely good practice with analog gear anyway. Okay, now the really fun part, connecting to the analog world.
Right. This is why you get the box in the first place. The manual outlines the basics. You need a MIDI source, keyboard sequencer, the MCV24 itself, your analog synth gear, and an audio monitoring system.
Standard setup. Does it give examples?
It does, and they sound really helpful. Examples of controlling VCO pitch, VCF cutoff frequency, but also how to use the MCV24's internal ADSR and LFO to modulate parameters on external gear.
Ah, so using the built-in modulation.
Exactly. Plus, specific examples using pitch bend and mod wheel from your MIDI controller to affect the analog sound via the MCV24. It even shows how to set up a basic 2-voice configuration using 2 outputs for pitch control. Really helps visualize how you'd use it.
That sounds practical. And it covers tuning, too, for volt octave and hertz volt.
Yes, it gives guidance on tuning the MCV24 to match both standards, including those calibration steps we talked about. And crucially, it provides example settings specifically for getting a Korg MS-20 working correctly in its native hertz volt mode.
That's super useful for MS-20 owners. Okay, looking ahead, the manual hints at future possibilities and expansion. Anything concrete?
Not super concrete, but intriguing. It mentions planned future software functions, implying firmware updates might add more features down the line.
Always nice to know it might evolve.
And it really highlights the potential of using the MCV24 with Doepfer's own A100 modular system.
Ah, integrating it into your rack.
Exactly. They list possibilities like MIDI-controlled frequency shifting, wavetable stuff, delay, pitch shifting, phasing, resonant filtering, vocoding, panning. Basically using the MCV24 as the MIDI brain for a whole suite of Doepfer analog modules.
So it becomes the central translator for a much larger system.
That's the idea. Even using external analog LFOs or envelopes from the modular system, but having their parameters potentially influenced or triggered via MIDI through the MCV24, it really positions it as a core integration piece.
Okay, so bringing this all together, it's clear the Doepfer MCV24 is way more than just a simple format converter, isn't it?
Oh, absolutely. It's a seriously configurable and really powerful bridge. It offers this incredibly detailed level of control plus extensive internal modulation that can genuinely unlock the potential of an analog setup when driven by MIDI.
So the key takeaway for you, our listener, is probably this. The MCV24 isn't just some utility box you stick in a rack and forget about. It's really a creative hub.
A performance interface, almost.
Yeah, it can massively expand what your analog gear can do sonically and integrate it tightly into a modern MIDI workflow. That level of customization, tweaking each output using the internal LFOs and envelopes, the whole modulation matrix thing, it just opens up this huge field for sonic exploration.
It really poses the question, doesn't it? With this kind of precise, flexible control suddenly available between your MIDI sequencer and your analog oscillators and filters, What happens next?
What new sounds are waiting to be discovered?
Exactly. What new sonic territories will you explore when you unleash that digital precision onto the organic soul of analog synthesis?
The possibilities, as you've heard, really seem as vast as your imagination. Now, maybe it's time to dive in yourself and discover what awaits at that fascinating crossroads of MIDI and analog control.